Hello, I'm Ben Henninger from LayTec Application Customer Support, and we will start a video series providing tutorials in how to operate and calibrate your EpiTT or EpiCurve. In this video, we want to focus on the pyrometer, the AbsoluT calibration, which points the pyrometer signal from your EpiTT and EpiCurve TT to the correct values. Each and every of your EpiTT and EpiCurve TT will be completely with all your parts, all the full optical signal chain will be calibrated in front of a pre-calibrated German PTB or NIST standardized black body calibration source. And we will put all optical paths in the light path which are as close as possible to the real viewports, viewport tube holes as in your site. So in best cases, our pepside calibration will be accurate also in your real-world calibration. But there are influences which will change this initial calibration. And in here, we are talking about how to on-site recalibrate it once after the installation is done. And from there on, in periodic times, to either double check that the temperature, very important parameter which you really need to be accurate in order to fully understand and use its capabilities. Repeat this and recalibrate it on site. So what could affect the company side calibration? And that is most case any small viewport coating. So for several reasons, although everything is very well purged, it could happen that there is over time a small accumulation of material inside the reactor part, which coats and sooner make more and more absorption losses. And in order to recalibrate and get the system back to the accurate temperature reading, we have our AbsoluT tool, which is an extra product, and it is matching for your type of EpiTT and EpiCurve wavelengths wise. So what it is an optical head. It's a hand-sized. It comes with a battery, charger, and a cable between battery and optical device. And these parts need to be inside the open reactor lid. That is for all reactor machines where you can open the reactor lid and you can place the AbsoluT handheld set close to the ceiling hole or shower head plane. And it mimics the spectroscopic part of Planck's thermal temperature spectrum in the wavelength range where we read the pyrometer signal. We will go in the second part of this video here in our test stand lab, and we will demonstrate this live and show all the tips and tricks to perform and prepare this calibration. Here just a quick preview. That is how the front side of the AbsoluT tool looks like. There's an exit slit, and that exit slit diameter is much wider than the EpiTT light spot, which passes the ceiling or shower head viewport tube and is focused to the plane of the wafer. And we have to position this exit slit in front of this much smaller EpiTT light spot. And that we will show in the second part. It's basically not that difficult. With a few tries, you will handle this in a minute. It is essential that you have a direct feedback what signal you see, because you need to place the handheld set in front of this sealing hole or viewport tube hole. And in that case, we have in our EpiNet data hub a screen, AbsoluT calibration, and this will show us the current value. Here you see when you get closer, it will rise. And here the local extremum, it's so the maximum we will see till now. And finding the maximum, so when the EpiTT light spot is within the exit slit diameter, since the exit slit diameter is much wider than the EpiTT light spot, we will look for a plateau. So we will place it, see signal here, and then move back and forth and verify that in a certain millimeter range, there's no change. That will become much more clear when we now go to our lab, and yeah, see you soon there. So we are now in our lab and we have a test stand. So we have the EpiTT. This plate is simulating the upper rectal lid. This is the area where then the rectal interior is. The wafers will be somewhere here. And so we have to prepare our hardware. So first we verify that the battery is charged. The charger, you just simply connect into a wall socket and plug the round connector here into that connecting terminal. You see when it's charging, it is an orange LED. Which will then turn green when it's fully charged. This one is almost fully charged, so it is good for us. And now we have to connect the cable, connecting the battery to our tool. We have two types of terminals. We have to pick the according one and connect it into here, gentle push, and then a half of a rotation of the screw there. We do the other side as accordingly. This is our AbsoluT device, and we connect this as accordingly. Gentle push, half a rotation. So now we place the battery somewhere in the glove box, that the remaining cable gives us the new enough space to freely move the AbsoluT towards the place where the light passes through our rectal lid. Then we switch on our device and we will see two indicating LEDs. The one which is next to the battery cable is showing the status of the charging level of the battery. So green means okay. And you notice that on this side, in the beginning, there was for a short period of a few seconds, maybe 10, an orange light. So the AbsoluT Generation 2 has an internal thermal stabilization electronics feedback loop. And when that is ready, so when all the components are at the constant stable operating temperature, you see green. So rule of thumb, 2 green lights, you are ready to go. The battery can supply the AbsoluT for at least 4 hours operation, so we have plenty of time. We do not have to rush. Generally, we recommend to do all of this outside of the glove box. Place the switched on ready tool into the load lock system. All parts are certified to be compatible with the pumping cycle, so there's no restriction. Just place it running into there, and then you extract it, and then we have it inside of our glove box. Here everything is open, easier to show. As we already talked about in the first part, we have to place the AbsoluT device in the optical axis, so below your sealing hole or viewport hole. And in order to do this, we need interaction. Just by hand, that would be too difficult. Therefore, we have in our EpiNet Data Hub a matching tool. So we will start the Data Hub by going down to this icon in the Windows taskbar. These are these two blue gears and the green triangle, and we select Open Data Hub Viewer. Then we select here Devices, and we scroll a little bit further down, AbsoluT calibration device. So it looks like this. It might be when you start up the first time that you see numbers from the previous recording, just quickly press the reset button. Next step is very important. Each of the AbsoluT devices have individual referenced, calibrated temperature, which our AbsoluT tool is simulating. It's creating a fraction of a spectrum which matches with our pyrometer. And that is calibrated on our side with a calibrated pyrometer. And the temperature, this specific AbsoluT, so you have to, each AbsoluT has an individual value, is in our case 900.3 centigrade. And this we have to type in reference temperature. So we type in 900.3, and if it's there, we are basically well prepared. And now we have already talked about these two timers. If you work with a colleague, then usually you don't need the timers, but if you need to do it perform alone, then you could use the timers to set a timer from starting data acquisition until you start to find the maximum signal, and from acquiring this data until it stops the data acquisition, the second timer. So these are these two timers, delay and duration. In the two-person operation mode, we don't need this. So now we press start calibration, and it is acquiring data. So now what we have to do is place our AbsoluT below the rector lid and then move back and forth until we find a plateau. So I'm moving the AbsoluT about a few millimeters left and right, back and forth, and the software is showing in the upper screen the relative maximum, and in the lower, the white background, that is the actual reading. So we just find some response and go from there. And yeah, in the beginning, it takes a few seconds. So the first one or two tries take a little bit time, but the more you practice, in the end, you will be able to reach it consistently within a few 10-20 seconds. So the only target with our manual movement is to find this relative maximum. So we have this tiny light spot of the EpiTT, which is about 2 millimeters in diameter, and that needs to match somewhere within this big exit slit. So the radiation, the emission is constant, is homogeneous across this diameter. That's why we have a certain degree of freedom where we find the maximum. So the maximum is not like a peak, but it's more a plateau. That's why you look for a value which appears to maximum. And then you move a little bit up and down, back and forth, to kind of map this diameter, and the reading should interact accordingly. And once we found the maximum, which is in our case performed, then basically we are done. And since the absolute for the EpiTT is, if you do not have ambient light, for instance halogen lamps inside your glove box, there's no interference between outside light to a reading. So therefore it consistently stays constant. So we can kind of put it away and press the stop calibration function. And what the software will now perform, as we heard in our first part, is that from the maximum value, the upper yellow one, it will calculate this correcting functions parameter, the delta. And now you have these two choices. Use this as a reference measurement, and automatically it will not apply the correction function. If you are if this is the final approach and you are happy with the result, everything makes sense, then you can apply the value by pressing this apply button, and then the value, the correcting function, is submitted to the internal data holding place, and it will be automatically applied for the next measurement. That was basically the AbsoluT calibration. So with a practice, after 3-4 tries, you are really comfortable in repeatedly getting the same consistent result. So thank you for your audience, and see us in the next part.